recorded anyhow. So here we go. After testing 312 cell phone batteries, 11 were found to be defective. What's the experimental probability? You should definitely hone in on that. It shouldn't throw you off, but you should expect that it's experimental. Why? Because it's based on what actually happened. Okay. So what's the probability of finding a defective battery as a percentage? So that would be 11 out of 312, right? Now, if you did that, 11 out of 312, you get that. You multiply that by 100, you get 3.53%. Okay, that's what they were asking you for. The closest answer, of course, is this one right here. I always want you to answer in 2 decimals, but in this case, that's all they had. Okay. Next, which of the following is another way of expressing 7 out of 52? So watch what I'm going to do here. Is perhaps not necessarily what most of you did, but I'm going to do this. 7 divided by 56 is 0.125. If I multiply that by 100, I get 12.5%. So I have all versions of that fraction there. And then I check. This one is definitely not it. 0.16, nope, because that's 0.12, right? And then some. Definitely not 7, right? So it must be that one. But just to make sure, I will go 1 divided by 8. That's 0.125, right? So indeed, D is your answer there. That's what you want to go with in that particular case. And 2,600 shipments of kitchen tiles, 70 were cracked, right? What's the probability that a shipment will have a cracked tile? So we go 70 cracked out of 2,600 shipments. And I will just go ahead and figure out what that is and multiply that answer by 100. And I get that this is 2.69%. Okay? The one that's the closest to that answer is 2.7 here, which is D. Right? So D is my answer there. Next. So I will say this, reading the question carefully is half of the battle, right? So make sure you read carefully, you highlight, right, as needed. A chocolate making team created 750 chocolate truffles. There's 200 dark chocolate truffles and the rest were made with milk chocolate. Okay. If you were to take a chocolate from the serving table, what's the probability of picking a dark chocolate truffle? Well, they give you how many there are that are dark and then a total of 750, right? And here it might get a little tricky, but watch what I'm going to do. This is my go-to, right? This is 0.2667 times it by 100 is 26.67%, right? So I have everything there, and then I check. I have a feeling that it's 27%, but you have to make sure that none of them would kind of be better than it. So 0.67 fails, right? I can go 23 divided by 30. That's 0.76 keeps on going. That's definitely not it, right? And 11 out of 15, sorry, that's 0.73. Also not it, right? So you've kind of eliminated those 3, so B is your best answer. So just watch for the best answer to get these right. So add it up out of 4. Every question is worth 1 for those multiple choice questions and see what you got there. Okay, you can do this, guys. A dog breeder is expecting a litter of lab puppies. In the past, the dogs she has bred, there was a litter of 23 puppies. Okay, 14 of them have been chocolate colored. The rest have been yellow. Okay, based on this information, what's the probability that a puppy in the next litter will be yellow? Okay, so probability of yellow. This is the proper way to start a probability question. You don't have to have that, but probability of yellow is 23 total, and you want the yellow, right? So you go 23 minus the chocolate labs, that leaves you with 9 yellow, okay? So that 9 goes in here. So that is your probability. That's all you need. I didn't ask you to state as a decimal or percent, so you just leave it like that. If you did state it as a decimal, you need to do this correctly, right? 3913 or 39.13%, right? So either one of those three forms will do. Let's just make sure this is separate. Let me change this. Instead of out of 1, we will make this out of 2. And the reason why is I will give you 1 mark for having the 9 somewhere, and then I'll give you another correct mark for actually stating the probability at the end. Okay, so 1 mark for if you have a 9 there, you get 1 mark. If you then state it like this, probability always has to be stated as a fraction, right? To begin with. So now express the probability of 5/16 as a decimal, percentage, and in words. We're going to get rid of the 2 as well, make this worth 3. That way it's just easier. So 5 divided by 16, that is 0.3125. No rounding necessary. Percentage, you just multiply that by 100. 31.25%. And in words, you can just do this. 5 out of 16, right? 5 out of 16. So 1 mark each, right? So this page is out of 9. Okay, there's 4 there, plus 2, that's 6, plus 3, that's 9. So this page is out of 9 marks. Give yourselves a mark out of 9. Okay. Back side. Fun side, right? Okay. Is that door closed? Or is it door closed? Door closed? Anna says yes, yeah, it is closed. Sorry guys, that's cabin life for you. All right. They put the teacher they don't like, they put them in the cabins. That's what they do. Okay, 13 out of 900. 0.0144. Okay, then I multiply that by 100 to get my percentage, 1.44%. Words, you just go 13 out of 900, like that. It's a bit of cheating there, but that they are okay. We are okay with that. Not with cheating, but using it like this. Okay, 56% it is. I'm gonna go from here to here. Remember, 56. There's 2 decimal places, so that it will be out of 100. If there had been more than 2, then you add a third 0, right? Next is 56 out of 100. And then you have this one. I'm going to go 0.29, which gives me 29 out of 100. And then I'm going to use my fraction to help me out with the words, right? I'm reading it off of that to get that. Then we're going to go 10 out of 241. I'm going to go straight to the fraction here. So 10 out of 241. I'm going to divide that. Go ahead. 0.0415. You multiply that by 100. You get 4.15%. Okay. So watch this. We're going to make this out of 6. Why am I making it out of 6? So every cell is worth half a mark. So every cell, if you made a mistake, take off half a mark. So give yourselves a mark out of 6 there, depending on how many you got right. And I'm going to zoom into that so you can see what you need to do there. I told you one of these is coming your way, right? There are no surprises there. Probably should leave you a little bit more room. Note it. Okay. Now let's solve some problems here using probability. So Springfield High School is holding elections for student council. The school has 968 students. That's worth noting. A poll was taken at a random sample of students to find out who they would plan to vote for. And this is your table with the results, number of votes taken. You should probably figure out the total already, right? So these are your candidates, but these are the number of votes they got from the poll. And so that's 106 polls. Okay. This is like your total for the basically the experiment. Remember, this is your experimental probability. And so what's the probability? Every time you see probability, you should think of a fraction, right? That a student will vote for Maryam. So probability that somebody's voting for a Maryam, it will be 26 out of 106. Okay. I will give you a mark for you having the 106 there somewhere. You get a mark there. You only get the mark here if you put 26 out of 106. If you put 26 out of 968, it's wrong. Okay? Will not give you the mark there. If you made a mistake by adding this up, which happens, like let's say you came up with 105, I would not give you the mark for here, but I would give you the mark for that probability. Okay? How many votes can Maryam expect to receive? This, right? Expecting, that's a prediction. You're making a prediction and you look it up in the notes. There's a formula for that. So basically, probability or prediction, you take the probability, which is 26 over 106, the probability that somebody would be voting for Maryam, then you multiply that by the larger sample. In this case, it's the whole school. Okay, so you're saying if this is true in a small scale, what would it be on a larger scale? 26 divided by 106, right? And I multiply that answer by 968, which gives me 237.43. That keeps going. I can't have a decimal answer for number of votes. So I will say 237 votes. If you left it as a decimal, I would take off half a mark for you doing that. Okay. Why is this only worth 1 mark? I told you it was going to be worth 2 marks because you're using the probability that you already figured out. So you're not coming up with a new one. If it hadn't had this step here, then you would have gotten 1 mark for this and 1 mark for calculating the right answer. Write the probability for a student to vote for Augustine. Probability of somebody voting for Augustine, and that would be 20, right? 20 out of 106. If you want that as a decimal, just divide them. That's 0.1887. You multiply that by 100. If you want your percentage, 18.68%. No, something is wrong there. 18.87. Sorry. Again, I didn't ask for all 3, so you can stop there. You can stop at the fraction. If I don't ask you for anything, I would just stop there because you could make a mistake and then that will cost you. So what are we at on this page? 1, 2, 3, 4, and 6. That's 10. So 10 for this page, 9 for the front. So that's a total out of 19. Total out of 19. Make sure your name and your last name is there. It makes it a lot easier for me to enter.
and